Hi everyone, today is Thursday, March 19th, and here is our video lesson for section 532. So real quickly, this is not an assignment that I gave you guys. You don't have the worksheet, but if you want some extra problems, here are the problems. Here's the work that goes with it. I'm just going to kind of scroll through this. Remember, this is a video, so if I'm going too quickly, feel free to pause the video. If you are interested on working on this worksheet, what I will do is I will post the blank version, but there's just something I want you to notice, and I'll show you. So if you notice these items, these similarity statements that I highlighted, if I show you the worksheet, look at 7 and 8. Okay, those similarity items are not given to you. So just kind of keep that in mind. Likewise, on this worksheet, 9 and 10, these are the original problems. But if you notice on the answer key, I had to give you the following similarity statements. So if you want to try the worksheet, it's not an assignment, it's not for a grade, it's simply extra practice if you want. And I'll post that along with this video in our Google folder. Okay, so today by the end of this video, I hope you can apply the triangle proportionality theorem to find side lengths and apply the angle bisector theorem and apply that when finding side lengths. So I'm basically teaching you guys two theorems, kind of basically two formulas in today's lesson. So here's what the triangle proportionality theorem states. If a line parallel to one side of a triangle intersects the other two sides of a triangle, then the parallel lines divide these sides proportionally. So if you notice, line DE is parallel to this side of the triangle AC. So based on that, I can say the following. Sorry, just trying to adjust the screen. All right, so basically I could set up the following proportion. So I could set up DB over EB. Okay, and that's what I did here. Let me kind of highlight that. So I could say DB over BE. Okay, and what happens is that will equal AD over EC. So I substituted the values for each of those segments and it does check out. The two fractions are equal to each other. Okay, so if you notice, I went kind of across when I set up my ratios, but if you notice over here, that doesn't need to be the case. I could actually stick with the same side. So I could basically set it up as DB, okay, over AD. Okay, and then I could set it equal to, so I'm kind of staying on the same side. Now I could set that equal to BE over EC. Hopefully the color coding helps. And if you look at this ratio, they are in fact equal to each other as well. All right, so that is just the triangle proportionality theorem. Sorry, just having some issues with my stylus. All right, here is the next theorem. It is called the triangle angle bisector theorem. And basically it says if we have an angle in a triangle that is bisected, okay, bisected means basically split in half, then what that does is the angle bisector divides the opposite side. So in this case, side AC, it actually splits it proportionally. Knowing this, I can actually set up a problem now like so. So I can set up side AB, okay, over CB. And that will actually be equal to AD over DC or CD. And in fact, this checks out. Or if you notice, so I kind of went from, if you notice, we have two triangles, ABD, and we have triangle CBD. So I went from like one triangle to the other, but I could also stick with the same triangle, and that's what I'm trying to show you here. So I said AB over AD, right there. And then that is also equal to, had I done BC over DC or CD, same thing, okay? And again, these two will equal. So that is the triangle angle bisector theorem. Now let's apply these. So example 1, find the length of segment BE, so what they're calling X. So first we need to identify the given information in this picture. These markings in red and black were not there. That's something I went ahead and did. So really, I want to kind of prove to you these triangles are similar. Okay, let me show you why. So if you look at triangle BDE, okay, if you look at triangle BDE, you see it has angle B. Let me outline that triangle. Now if you look at triangle BAC, you can see those two triangles share the same angle. So angle B is congruent to angle B by reflexive property. Also notice they told us, you can see it right here with the arrowheads, they told us segment DE and AC are parallel. Okay. And then since we know that those two sides are parallel, we know that angle BDE and angle BAC are in fact congruent. If you remember from Math 1, when you guys did parallel lines cut by a transversal, we would say that these angles are same side or corresponding angles. Okay, so that's why those angles are congruent. Therefore, my two triangles, triangle BDE and triangle BAC, are similar by AA similarity. Okay, because I know the two triangles are similar, here's the proportion I set up. So here's my proportion. Okay, I did another little setup, but if you notice, I am still going to cross multiply the same terms together. I'm going to still multiply 5.5 with 3. Because when I set up my proportion, I was consistent. Here's my math, my algebra, and here is your answer. All right, so this problem, there's actually a lot going on, okay? I'm actually going to do this problem in two different solving methods, okay? So the first method I'm going to apply is the triangle proportionality theorem, okay? The new theorem we're learning. So if you look at what's kind of given to us, sorry, excuse me, I'm telling you guys segment AE and CS are going to be parallel to each other. So for that reason, I'm going to do 18 over 3x minus 4 is equal to 12 over, okay, so I know that segment ES is 8 because I told you that KS is 20 and KE is 12. So how do I get this little segment? 20 minus 12. Okay, so here's my proportion. And if I continue, here is the algebra. So doing it this way, so again, I'm going to cross multiply. I hope you're feeling comfortable with the algebra, and I get 5.3 repeating units for side length of x. Okay, all right. Now here's the way we used to do it. Before I taught you the triangle proportionality theorem, we would just basically use similar triangles. So look at what I did. I actually took triangle KAE and I redrew it over here. Sorry, excuse me. So sometimes in this geometry unit, it helps if you actually kind of split the picture and draw two separate triangles. And then I took this larger triangle KCS and I drew that over here. Okay, so let's see if you understand. So this is given that this is a length of 18, this is given this is a length of 12. Now how did I come up with this larger side length of KC? Well, I have to take CA and add it to KA. So if I take 3x minus 4 plus the 18, combined like terms, I know that segment CK is 3x plus 14. And then if you notice, KS was given to us that it's 20. So here are my pictures for the two similar triangles. Okay, and now here is the algebra. So I did using the smaller triangle. I did 18 over 12 is equal to 3x plus 14 over 20. And I do my cross multiplication. And if you continue with the algebra, you will notice you get the same answer. I just wanted to show you there's two different ways to get the same answer. This side over here, okay, applies the triangle proportionality theorem, which is what we're practicing and learning today. And this side over here is just using properties of similar triangles and setting up proportionals. All right, so I just want to quickly go through this example. Okay, this example can be found on page 82. And after this example, because of the videotaping tool I'm using, I'm going to stop it and then continue in a second video. So real quickly, again, let's use two different methods. So if you notice here, I have triangle DEC, smaller triangle, and then the larger one, ABC. Okay, and that's what I'm doing here. I'm using similar triangles. And what is side BC? Well, 9 plus 6, that's where I get my 15 from. Okay, and then if I wanted to try the triangle proportionality theorem, I could just say that 9 over x is equal to 6 over 5. Because again, I noticed that they told me these two segments are parallel to each other. So similar triangles, here's my setup. Triangle proportionality theorem, here's my setup. Okay, regardless of which method you use, you get the same answer. Okay. All right, I hope you're understanding this, and please continue watching the next video.